Hello, this is Ole Collins, and this is my video slash demo for the final project for CPSC 5002. So I know I've said it the last two times, but I'm really going to try and keep this video from being a 20-minute video. I'm going to try and keep it under 5 minutes. So let's go over my code and then go through some examples and then be done. So first up, we have this abstract vehicle class. All it takes is a license plate, so each vehicle is uniquely identified by its license plate or license number. And then we have this calculate fee method. The reason nothing's defined is because we actually use polymorphism, because this abstract vehicle class is more refined into a car class, so that's any four-wheel vehicle car. So we see we use super just to grab the constructor from vehicle, and then cars get a 1.0 multiplier to their fee. So nothing happens. Cars just get the plain old regular fee. But if we go over to the motorcycle class here, we see a lot of the same stuff. But if we go down here, we see motorcycles actually get a 0.8 multiplier uh, to their fee. I explain more of this in my PDF or written report. But motorcycles take less space, they cause less traffic, they generally leave faster, so therefore we should charge them less. So those are my two kinds of vehicles. In the future, if someone wanted to update this app, you could add a third class for like RVs or a fourth class for 18 wheelers or even a class for bikes. Um, as we see from these two, it's really easy to um, extend this abstract vehicle class. So then now we have our vehicle set up. The things that are going to be entering our parking lot. Let's actually start setting up our parking lot. And this is where the parking spot Java file does. So I thought this was a really um, cool example of object-oriented programming at work. So what is a parking lot? Well, it's a bunch of parking spots all put together. So why don't we create a parking spot class? And then taking this parking spot class, we can create a list or array or a graph of them, and that can represent our whole parking lot. So I thought that was a really beautiful example of how object-oriented programming kind of breaks down problems into these smaller pieces. So this is our class for individual parking spots. Each spot is uniquely identified by an ID and whether it's occupied or not. We can see this in the constructor. And then for each spot, we just have a bunch of some getters and setters. So we can get a spot's ID, we can get if it's occupied or not. We can change its occupied value or set its occupied value. Then below here, this method is to kind of massage the output that the user will see. So the unique IDs or the IDs here, without this method, they'd be, spot one, spot two, spot three, spot four, spot five, etc. The thing is, if we have a parking spot with two or a parking lot with 2,000 spots, um, then it'd be kind of unwieldy for the user to see print into their screen. Parking spot 1,966 is reserved. Please choose another. So that's what this method does is it massages that output. So it divides the ID. Chose module 10 here. It could be anything. Essentially, all the spots instead become like A0, A1, A2, A3, and then you go down to B, B0, B1, B2, B3, et cetera, and it just goes through the alphabet. So it kind of condenses it all, makes it a little bit nicer to look at. But like I mentioned, we have our spots. So let's combine them into our parking lots. And this is kind of the main huge class that does work for this project. I even made a list here at the top of all the things it does. Here's some things initialized. You see we have a list of parking spots. That's our parking lot. We have some maps that track the vehicle where it's parked. We also track the license plate associated to a vehicle. This is actually so when people are leaving, they can just type in their license plate number, and we can immediately take that plate number, find the associated vehicle, and then go from there. Here's our queue for the waiting list. And then we set up our adjacency matrix, which is going to be to implement our Dijkstra's um, nearest parking spot algorithm. Again, I did this in homework 9 as well. This is just a class node. It implements comparable because comparable allows us to compare two nodes. The metric will be, which node is closer to the entrance. And so we construct our parking lot. We fill the spots. Spot one, spot two, up to the number of spots. Their IDs, go from 0, 1, 2, 3. Um, this is constructing our adjacency matrix. We're making sure it has the right dimensions. Then we get the number of spots. We get the fraction of occupied spots. And what this does is it allows us to implement our dynamic pricing. So, if the occupancy rate is greater than 0.8, we increase the fee by 10%. And then we combine this because if you recall in the previous packages, different vehicles get different fee multipliers. So that's what this does. It takes our vehicle type multiplier and multiplies it by our dynamic rate to get the total final price. And then I go more into this in the written report, but this by near spot, that's our implementation of Dijkstra's spot finding algorithm. So let's go ahead and look at some examples. So this is kind of the final file where the actual app or the user interacts with our system. So let's try it out and see what happens. So if we run it, we see some options pop up. You can enter as a car, enter as a motorcycle, exit the vehicle from the lot, show the lot status, or quit. So let's do option 1. Oops. So Alaska standard license plate number, let's just enter 1. Okay. Let's enter 1 again. Let's enter another car. Let's say its license plate is 2. And then let's choose option 4 to see what our lot is looking like. So we scroll up. We see the first spot is indeed occupied, and the second spot is indeed occupied. Let's enter a motorcycle. So that'd be option 2. Let's do license plate is 3. Let's check our lot status. So we see, yep, the first three spots are indeed occupied. If you go here too, when we eventually entered our motorcycle, entered the plate, it prints what spot the user gets assigned to, as well as what the estimated fee is, which is indeed $16 for motorcycles because they get that little discount. Let's try exiting a vehicle. So that'll be option 3. Let's say the first vehicle wants to leave. It says, vehicle 1 left spot A0. So let's check that. We go up here and we see indeed the first spot is now indeed free, and the other two people are still there. Here we can see the current occupancy. I probably should have rounded this. And we can see there is no wait queue size. So if we did enter eventually 14, we should have a queue start going. But let's hit 5, and that breaks us out of our application. So thank you for listening to this. Thank you for a wonderful semester. I certainly learned a lot about programming. This is the most I've actually ever learned about programming just from doing all these assignments. Thank you. Have a good break.